When people first get into data science and machine learning, they just want to take a look at the data, plug it into a few cool models, and see what they can get. However, that's not going to work in the long term. You want to use the data science lifecycle. Now, there are already a few frameworks out there to choose from. Popular ones include CRISP-DM and OSE-MN. However, I found them less than comprehensive. So I want to suggest a 5-stage lifecycle that gets you from A to Z quickly and smoothly. Now, this includes business and data understanding, data prep and EDA, model selection, tuning and ensembling, and finally, validate and ship. Now, I wrote a whole Medium article that explains all of this and asks a bunch of questions so that you can use it as a checklist as you go along. The link is in the description below. However, if you want to stick around, I'll give you a brief outline. Now, for business and data understanding, we want to understand the problem and we want to understand what defines success, what sort of decisions they're going to use the model for, and what sort of limitations are we faced with. For example, budgetary, time, regulatory, and is this even technically possible? And then we want to move on to like data acquisition, and we want to understand where are we getting this data from? Do we have historical coverage? What sort of security do we need for this data? Can we get it extracted from its source and loaded securely in a database? After we've answered these, we can move on to data prep and EDA. Now, in every life cycle, data prep and EDA take up the lion's share, and there's no exception here. So with data prep, we're first going to do data. We're going to do data ingestion and loading. We want to pull the data out from its raw source and get it into a nice, clean, searchable format. So we want to understand whether or not that's a JSON, a CSV, a Parquet, what sort of partitioning schemas we're looking at. And once we got it out and it's nice and searchable, we want to move on to data cleaning because there are a lot of errors and we want to fix any sort of quality issue that would that would produce misleading analyses or that would interfere with our model's ability to make prediction. So we're looking at things like duplicates, nonsensical values, like someone's 2,000 years old. We want to look at consistent representation of categorical variables like New York versus NY. These are the sort of things we want to look at, especially like outliers and missing data. And once we have that all fixed, we can move forward. And with that, it's exploratory data analysis or EDA. And here we want to uncover patterns and test assumptions. We want to see what sort of distributions are we dealing with? Are there nonlinear relationships? Are our hypotheses about what affects the end result true or false? Can we make those sort of predictions here? Are there variables that are highly correlated that would affect our models downstream? We'll return to EDA frequently in any sort of pipeline. So keep that in mind that this is not one and done. You oftentimes have to come back to EDA. Next is feature engineering. So once we have an idea of the raw data, what the raw features are, we want to sort of understand, well, how can we raise the information that we're feeding the model? We want to get more signal and reduce noise. And so we create combinations of these raw features to new features, which are called engineered features. And these should be predictive. And that we also want to make sure that they have proper encodings. So we want to have one hot encoding for categorical. We want to have bidding for any sort of continuous data that we can't transform into a Gaussian if models are sensitive to non-normal distributions, things like that. And once we've done this feature engineering and we're settled on it, we need to make sure that this is combined into a pipeline. And the reason is we want to prevent data leakage from our validation set into our training data. This means fitting on training data and then putting transforms onto the training and validation data. So for example, if you want to take the median age and you want to impute that into missing values, you don't want to include the data from the validation set when you're imputing your age. You want to keep that separate. Well, when you're calculating your median. So that's what you're going to do at the final part of the feature engineering. And once you have that, you can move on to model selection. With model selection, we want to avoid doing anything fancy. We don't want to do hyperparameter tuning. We simply want to figure out what are the candidate algorithms and to choose the best one before we waste any time hyperparameter tuning models that fundamentally are mismatched to the data or the problem. So first step, select a few base learners, as in KNN, support vector machines, linear models, decision trees, and figure out what sort of criteria you're going to use. What sort of metric? Is it accuracy or PRAUC if you have unbalanced classes? And you want to choose a winner on the data. After that, then you go on to tuning and ensembling. So from your model selection, choose 2 or 3 that perform the best on the metric that you define, and then work with all the hyperparameters. You can use Optuna, for example. There are other hyperparameter tuners out there. You can use grid search, random search, or Bayesian hyperparameter tuning. And then you want to see if you can get that metric as high as possible. And then after you've done your hyperparameter tuning, you want to move on to ensembling, because frequently the best performing models aren't from a base learner or even a tuned base learner. They're actually a combination of base learners that have been tuned. And there are various ways of doing this. You can do boosting, bagging, you can stack the models. But the point here is you want to see whether or not a combination of those models performs better than any of the individually tuned models. And then after you've done tuning and ensembling, you want to move on to your validation step. So validation and shipping. So here we want to make sure we actually answered and come up with a solution to the business problem that we started with. We want to see whether or not either one of those base hyperparameter tuned models performs the best, or whether or not it was an ensemble. We want to decide whether or not there's selection thresholds that we need to define, for example, with regards to classification. And then we want to see whether or not we overfit the data. Once we're sure that this is the best model based on the validation, we can move on to interpreting and communicating that either that's with documentation, we are maybe putting in a sample prediction and looking at the Shapley values to see what was the most important features. Here again, we're trying to confirm or disprove hypotheses that we had early on regarding what was important for the business problem. And then afterwards, we want to work on deployment and monitoring, because although we've just created a model that's predictive, it's not always going to stay that way. Data drifts, and we also can't really send somebody a notebook. We have to have this either in batch prediction. We have to have either we have it embedded or have an API endpoint that people are making predictions against. And we have to make sure that goes through a CI/CD process. We have to make sure that the infrastructure is there, and we have to monitor the model to make sure that as the statistics on the data that it makes predictions on, when that drifts, we monitor it and retrain the model on the new data so that we're always working with a predicted model. And the very last step, and this was long, thank you for staying with me, is a meta step. So we want to really take a look, reflect, and look for continuous improvement in our process. So what were the bottlenecks to the process? How can we make this occur faster? What sort of documentation do we need to provide for this model development? And that's it. That's all 5 stages from beginning to end. And if you go through my article, you can ask these questions of yourself and make sure that you have full coverage and you're not missing anything. If you're interested in any more tips and tricks, follow me on X at Coffee First, and you can find when I put out new articles and videos.